Hello everybody, my name is Brandon. Today I'm going to be talking about my Arduino fan project. So what I have here is a pretty bog standard dumb fan. It's controlled by this remote here on the wall. So see, if we press button 4 for speed 4, sends out the command to the fan, it'll set it to speed 4. We also have some other buttons that are more like toggle switches kind of. So we have this light button here, and what this will do was it'll just send out a light command to the fan. So if the light's off, press the button, turns the light on. It's a little busted on these fans because they're cheap. I send it again, turns the light off. And I wanted to devise a solution for this so that I could control it from my phone or from my desktop. These fans are in an apartment, so it's not exactly easy to go ripping the controller out of the wall or go ripping the controller out of the fan and putting in, a dedicated smart home solution. So I actually devised a method of kind of intercepting the controller and the fan's communications. So what I ended up using was an Arduino R4 Wi-Fi, I believe it's called. It's the one with the matrix. I used our Texas Instruments CC1101, which is a sub-gigahertz transmitter. I'm not sure of the frequency ranges on it, but it's pretty good, and it definitely covers what this fan needs. On the software side, I used a piece of software called Home Assistant, integrated that with another piece of software called Mosquitto Broker to use MQTT, which is a protocol I'll discuss a little later. And we bring them together. It's a pretty good solution to controlling the fan. So yeah, without further ado, let me show you how I kind of developed this, the thought process I was going through, and we'll show you the finished result in the end. Alright, so before we talk about the software involved, let's actually talk about some of the hardware first. So as part of the investigating process to figure out what we actually needed, this was very helpful. This is an RTL SDR module, and basically what this is a software-defined radio. You'll hear that called SDR a lot. What this will allow you to do is you plug it into your computer. You can tune it to any frequency, I believe below like 1.4 gigahertz. So you can tune into VHF radio, UHF radio. Appliances is a big one too, so this will do the 303 megahertz, this will do the 433 megahertz. This will cover all the bases for like appliance communication. So this is very useful if you want to do this project yourself. I highly recommend getting one of these, because if you have a mystery frequency like my fan did, this will this will reveal it right to you. So that was a big help. And these kits are cheap too. I think this one was like 40 bucks, I want to say. And here is the actual job doer itself. So this is the Arduino board that I'm using. This is the Arduino itself. You can see this is the R4 or Uno R4. Here is the CC01 board. It's not actually attached. I just have some like sticky tape on these little headers here that are connecting this board to it. So if I could just rip it out, but you probably shouldn't do that. So these are two separate boards. This just connects with these little one-wire cables. So you have these on power, 3 volts over here, and then communications as well right here. So yeah, fairly straightforward for hardware. This was actually a little hard to find initially because it wasn't what I was looking for. A lot of projects online will tell you that by default these kinds of fans are always going to be 433 megahertz. So I ended up getting a bunch of these modules. Now what you can do with these is you can actually either do like I did here with these little connectors and plug it into the board. I put mine on a breadboard, so I had this is I think the receiver, and these also come with a transmitter too. Let me see. Yep, so these come in 2 pieces. So this is a 433 megahertz transceiver and receiver and transmitter. So you'd put them on a breadboard and then you'd send the signal through them. The problem is they'd only do 433 megahertz. So that didn't work for me because it was a really weird frequency. So that's why we settled on the CC01. I think that was the best decision, because you can also do, if you got new fans, you could adapt it to that in the future. So there you go. For hardware, pretty simple. All right, so the software side of things, let's go ahead and work through it. So what we have here is our main libraries that we use. So for this particular solution, this is just for the LED matrix that's on the Arduino R4. This is the driver we use to talk to the CC1101 chip.
this is a library called RC Switch, which made handling the actual commands to the fan very easy. This is the Wi-Fi library for the Arduino. This is another piece of important software. This is the pub sub client. Now what this utilizes is the protocol called MQTT. We use that to communicate with Home Assistant. So you can see here we just have some things defined. So we have our what our device is going to be called to MQTT. Some topics. Now topics are basically it's kind of like a URL, and it points to what that device is talking about, or what point of data is being tracked, or what should be set. So you can see that we have our state, and how this actually works is, well, half state, half set. So set is the command that is sent from Home Assistant to this controller, and when it receives the set command, it'll actually send out the radio signal on the board to the fan. When it receives the state command, it sends the state command. So this controller will send out the state command, and Home Assistant receives that. So it's kind of like a two-way trade kind of thing. Because of MQTT, state comes back to the controller too, but we just don't handle that. Here's our frequencies. So you can see from the testing, we found that this was 303.85 megahertz. Here are some LED matrix stuff. All right, so instantiating objects here. This is one of the main things that we store all the fans data in. This is a fan struct. So you can see here we store the fan identifier. This is the 16-bit identifier, which is part of the 24-bit command that the remote sends out. So I think for mine, it's this one. It's the 0111. I'm not going to read that out. This is the light state. Is the light on or off? Fan state, fan direction. All this is pretty self-explanatory. And this is the speed from 1 to 6. Now this is another array. This is fan commands. So this actually maps, from my testing, what commands map to. We handle them as integers. So for example, I do 0 is toggle light, 1 is speed 1, 2 is speed 2, 7 is stop. So this just kind of is how we internally communicate the numbers. And this is cool because I actually, the integer numbers correspond to the speed, so it makes things a lot easier. And then here's actually a special command too that I'll talk about in a little bit. This was actually determined by testing through every single combination of numbers that the fan would receive, and I ended up finding this combination of numbers. So it's 11110000. So what this will do is it will reset the fan, which means it'll set it to speed 0, it'll set it to be blowing down, it'll set it to be lights off and maximum brightness when you do turn the lights back on. So this is really cool because before I discovered this, I had no way of keeping the state of the fan. However, with this command, if we ever want to, say, resynchronize the fan, which we do handle in a function here, we can send out this special command that I found, and that will set the fan to this state, so we know the fan state, and then I'll send out what the fan should be. So say we could have it resynchronize at 12 a.m. or something, so if the controller thinks it's blowing down but the fan's blowing up, it's going to say, hey, reset back to absolute 0, to the absolute 0 I know, and then the controller is going to send out what it thinks it should be, so whether that's blowing up or blowing down. So that should help resynchronize it and keep it in order without me having to manually intervene. Here's just instantiating the fan object. And here we go ahead and initialize some objects, or initialize the libraries. Alright, this is just mostly debugging stuff. This isn't really important. Here is how we handle incoming commands from the radio. So this is part of being aware of the controller on the wall sending out commands. So by default, this is going to listen for commands that are coming from that remote. So we'll see if command's available. We'll load the receive little matrix thing so we can see it. This will actually run it through a decoder I have called decode command. In this function, we pass through the binary that we received from the radio, and then it actually determines, like I said earlier, since we store the command in an integer and the fan in an integer as well, it'll convert that binary to that integer. It'll also see if it's not our fan. So for example, my bedroom fan is going to be 0 in the fan array. So if I send out, speed 3 from my fan, it'll say it's fan 0, command 3. Yep, and then it'll match it, make sure it's ours, and then I believe it will update the fan state from here. So it'll update our internal record of the fan. The controller didn't do anything, it's just resynchronizing. So it'll update the fan state, and then it'll send it back to MQTT to fortify that we did update from what the command was. This is to check if MQTT is still working. This is to check for MQTT commands. This is some special stuff too that we have to do for the radio. So the way this communicates with the Arduino is over SPI. So we have a few connectors. We have like the signal, power, and then we have the SPI communications. So this will allow us through this little driver library to initialize the radio. We set the modulation mode. So there's a couple different modulations that I had wrote about on my website. There's ASK, which is amplitude shift keyed, FSK, frequency shift keyed. This fan uses the simpler one, which is amplitude shift key, so we set it to 2. On-off keying as well. This is a cool part of the library too, the RC switch, so we can set the protocol, which is just basically how the numbers are encoded into the actual signal. And then we do this so it sounds like the remote as well. And then we'll set the pulse length, which is just to get it more closer to the remote sound as well. And then we set the radio to receive by default when we initialize it. So that way it's listening by default right out of the gate. This is to set up Wi-Fi, display, and here's that radio swapping function. So whenever we are not transmitting, we're always going to be listening. So this is called by, I believe when it receives a command, or when it wants to send a command, it'll set it to enable transmit, and then it'll immediately set it to start listening again. So we only call this when we're ready to send out a command to the fan, but by default we're going to be listening like this. This is to initialize MQTT, nothing real interesting here. This is the decoder command. All right, this is the MQTT callback. So whenever we receive a command from MQTT with any of these topics, I do have a set few like the set ones, we're going to handle it here. So this will, the MQTT library pub sub client will call this function, and just a bunch of annoying C++ stuff here. But you can see if the action, which is a part of that topic, is set, then we're going to see what's after set. So if it's set, if it's on, we're going to turn it off or on and just keep the speed how it is. If it's speed, we're going to turn it on and then set the speed. If it's light, we're going to toggle the light based on how we think the light is. Or if it's direction, we're going to toggle the light based off how we think the direction is. So this is pretty straightforward. And then this just publishes it back out. So whenever we get a set command, we do the update fan state, and then that'll publish back to MQTT. So, and then it sends it to the MQTT and then back to the controller. So it's a little weird. But since we don't handle the state commands, it's not going to cause an infinite loop. You think it would, but it doesn't. All right, and yep, that's that. Here's the update fan. So this will just, based off the fan integer that I input and the command, it will update the struct accordingly. And then, yep, that'll print the fan status to console. So see if we do it here. Yep, so it just did the print the fan status. So it shows we received from MQTT home Arduino fan 1 speed set, and then here's the payload 3 because we set it to 50%. That's the halfway point. So then it sends out the command, updates the MQTT status, and then look, it sent out the speed again. So it ended up doing it again, but it doesn't loop. And then here's the sync function that I was talking about earlier. We haven't quite implemented this yet, but what this is going to do is, since the reverse command is so rare and it's rarely used, maybe twice a year when the seasons change, we'll do the sync operation whenever we change the direction. So what it'll do is it'll zero out the fan, and then we'll send what we want it to be. So we know it's going to be down when we reset it. So if we want it to be down with nothing, or if we want it to be up, we'll send the reverse command. And then here's the two commands that we use, or two functions that we use to send out the command. So assemble radio command is when I want to turn the integer, fan integer, and the command integer into an actual radio command. So the 24-bit command that I was showing. So this will just basically pull the identifier from the fan struct, and then it'll pull the command from the command array and throw that together. We're going to return the radio command. This is usually, these two are run together, so we'll do send radio command, parenthesis, assemble radio command. So this gets the radio command character array, transmits it out, does some stuff with the matrix here, does some serial output, And yep, that'll toggle the fan. This is just more debug stuff, more debug stuff. Here's a little helper function. This will convert decimal numbers to binary. But yeah, that's pretty much it code-wise. So this code is available on the GitHub for this project. I try to simplify this just whenever I have time. It's pretty simple as is. It could still be better, I think. But other than that, pretty cool code. It's pretty functional. I haven't had any big issues with it. So yeah, I'm proud of it. And I guess I'll just wrap up by showing you just some of the console output here. Yeah, it shows the fan status identifier. All right. Oh, and here's another important part too. So on the Home Assistant end, this is configuration.yaml, sorry, and we could set this up to automatically import itself into Home Assistant. Theoretically, you could. It's just easier to do it this way manually. So you can see we define an MQTT object, fan, an MQTT fan. So then we put the info in here, name, bedroom fan, unique ID, Arduino fan 1. Here's the topics I was talking about. So the state topic to synchronize the state is going to be, on state. So see, that matches here. The command topic, when I do something in Home Assistant to send it to here, is going to be on/set. And see, that maps to the controller as well. And then here's just some kind of logic trees for how the UI should match up to like what command is sent. So if the value is 1 on that little slider thing, it'll send out the payload of 1. If it's 5, it'll send out the payload of 5. Or I'm sorry, this is actually value, so this is what it'll show. And then this will show, or this will send out the command. So if you set it to 5 on that slider, then it'll send out 5. If you set it to 0, it'll send out 0, which is going to be the shutoff command. And then here's another one for the light. The light is pretty simple. It's just kind of a binary device. So we just have the state, is it on or off, and then we have the set, hey, turn it on or off. Yep, speed ranges as well. Pretty straightforward. All right, so here's the finished product. So you can see it's pretty easy, intuitive interface on Home Assistant. All we got to do if we want to turn it on, we just press the power button. By default, that goes to 50%. And also that was its last recorded state, so boom. Fan just turned on with the 50%. Say we want to turn it up a little higher, so we'll put it to 100%. Controller sends out another command, it's going to 100%. Here's the cool part too. We can also change the direction. And this is the difficult part because the fan doesn't really keep the state. So we have to make sure that, it keeps the actual directionality, because as far as the controller knows, it has no idea which direction the fan's going. So this is why we actually implemented that reset command as well. All right, there you go. Look, it's spinning in reverse. I don't like that, so we'll put it in forward. Boom, goes right back, flips back to that. Wait for it to spin up here. And then here's the cool part as well. So the best part about this is that it's completely rent friendly. I didn't touch any of the controllers, I didn't mess with anything. And the controller, the Arduino controller is actually set up to listen for commands from the wall remote. So if I set it to speed 3 on the wall remote, it updates in the app, right? If I set it to speed, 5? 83%, it updates in the app as well. We can stop it on here. We can do the light as well. It's not going to show on this screen, but it'll do the light. And direction as well. So see at the bottom it says forward, reverse, forward. There you go. So overall, well, I think that messed it up, but still needs a little bug fixing, but... Oh, hold on. Nope, it kept its state. All right, that's good. That's good, it kept its state.